Hello there, and welcome to Earth's History, where we examine the deepest questions about humanity's place in time, where we explore the possibility that recorded history represents only the most recent chapter in a much longer story, where we ask whether the 10,000 years of civilization we know about might be preceded by dozens, hundreds, or even thousands of previous civilizations that rose, flourished, and fell, leaving so little trace that we walk over their remains without recognizing them, where we contemplate the unsettling possibility that we are not the first technological species to inhabit this planet, but merely the latest in a long sequence of intelligences that have emerged, built complex societies, faced existential challenges, and either transcended their limitations or succumbed to them, vanishing so completely that their successors, us, have no memory of their existence. If you've ever felt that human progress seems too rapid, as if we're remembering rather than discovering, if you've wondered why ancient structures sometimes display sophistication that seems anomalous for their supposed time period, if you've contemplated the vast stretches of geological time, millions and billions of years, and wondered whether intelligence could have emerged before us and left traces we haven't recognized, if you've sensed that the story we tell ourselves about human uniqueness and novelty might be comforting mythology rather than verified fact, masking a deeper truth that we are neither first nor alone in Earth's history, but participants in a pattern that has repeated many times before and will likely repeat many times again, you're beginning to touch on one of the most profound and disturbing possibilities in all of human thought, that civilizations are not rare, precious, and permanent achievements, but common, ephemeral, and cyclical phenomena, appearing and disappearing across deep time like waves on an ocean, each believing itself to be the first and only, each leaving behind evidence that subsequent civilizations might or might not recognize. Wherever you are right now, I hope you're comfortable, settled, ready to contemplate questions that have no definitive answers, to examine evidence that points in multiple directions, to hold in your mind the uncomfortable tension between what we know for certain and what we suspect might be true, to consider that the ground beneath your feet, the mountains on the horizon, the sedimentary layers exposed in canyon walls might contain the compressed and nearly obliterated remains of civilizations so ancient that even their bones have been recycled through the rock cycle, leaving only the faintest traces, subtle chemical anomalies, statistical improbabilities in fossil distributions, geometric patterns in geological formations that might be natural or might be the last whispers of intelligence that existed before us. If this exploration into the possibility of previous civilizations changes how you see Earth's history, if it makes you wonder about the detectability of our own civilization in the far future, if it inspires humility about human achievement and concern about human permanence, if it makes you realize that intelligence might be common but survival might be rare, I'd be grateful if you'd like the video, subscribe to the channel, or share it with someone else who understands that the most important questions are often the ones we can't definitively answer, the ones that force us to confront the limits of our knowledge and the vastness of our ignorance. So settle in. Let your breathing synchronize with the slow rhythms of geological time, where thousands of years pass like heartbeats, and millions of years are but moments in Earth's 4.5 billion year existence. Let your mind expand to hold timescales that dwarf human history, where the entirety of recorded civilization, from Sumerians to present, occupies less than 1,000th of 1% of Earth's age, a statistical blip, a moment so brief that if Earth's history were compressed into a single year, all of human civilization would occur in the last few seconds before midnight on December 31st. And let's begin our investigation into how many civilizations might have come before us, examining the evidence that might indicate previous intelligences, the mechanisms that could erase their traces, the timescales we're considering, and what recognizing our potential non-uniqueness would mean for understanding who we are, where we came from, and where we might be going. Defining civilization and before us. Before we can count civilizations, we need to define our terms. What is a civilization? Narrow definition: complex society with cities, writing, monumental architecture, social stratification, specialized labor, and centralized government. By this definition, Earth has had perhaps a few dozen civilizations in the past 5,000 years: Sumerian, Egyptian, Indus Valley, Chinese, Olmec, Maya, etc. Broader definition: any society with substantial population, technology beyond immediate subsistence needs, cultural transmission of knowledge, and capacity to modify environment at significant scale. By this definition, civilization might extend back 10,000, 50,000 years. Neolithic settlements, megalithic builders, advanced hunter-gatherer societies. Technological definition: society that has developed technology capable of leaving lasting impact on environment, agriculture, metallurgy, construction, eventually industry. This is the definition most relevant for our investigation because technological civilizations are most likely to leave detectable traces. Intelligence definition: any species that develops complex cognition, tool use, social organization, and cultural transmission, not necessarily human. This is the broadest definition and allows for non-human civilizations, other hominids, completely different species. For this investigation, we'll primarily use the technological definition while remaining open to the intelligence definition. We're asking whether technological civilizations capable of significantly modifying their environment have existed on Earth before our known historical civilizations. What does before us mean? Before recorded history 10,000 years ago, civilizations that existed before Sumerian cuneiform and Egyptian hieroglyphics, the earliest writing systems marking the beginning of recorded history. Before anatomically modern humans 300,000 years ago, civilizations of earlier hominid species, Homo erectus, Homo heidelbergensis, Neanderthals, Denisovans, or unknown species. Before the genus Homo, 2+ million years ago, civilizations of non-hominid species, other primates, completely different evolutionary lineages, species that went extinct leaving no descendants. Before complex life, 500+ million years ago, civilizations during earlier geological periods, Paleozoic, Mesozoic, even Precambrian. The deeper we go in time, the less likely we are to find evidence because geological processes destroy, bury and recycle crustal material. But unlikely to find evidence doesn't mean didn't exist. It might just mean evidence has been destroyed. The key question: how far back should we look, and what evidence would constitute proof of previous civilizations? The Silurian hypothesis. Could we detect ancient industrial civilizations? In 2018, NASA climate scientist Gavin Schmidt and astrophysicist Adam Frank published a thought experiment called the Silurian hypothesis, named after an intelligent reptile species in Doctor Who. The question they asked: if an industrial civilization existed on Earth millions of years ago, would we be able to detect it in the geological record? Their methodology: examine what traces human industrial civilization, past from 200 years, will leave in geological strata, then extrapolate to determine detectability over millions of years. What human civilization will leave behind? 1. Carbon isotope anomaly. Burning fossil fuels releases carbon with distinctive isotopic signature, depleted in C13 because fossil fuels come from ancient organic matter that preferentially incorporated C12. Detectability. Carbon isotope ratios in sediments and ice cores will show a spike during the industrial period, 1800 present. Duration. The spike will remain detectable for thousands to millions of years, though it will become less pronounced as the isotopic anomaly gets mixed into the carbon cycle. Confounding factors. Natural carbon releases, volcanic eruptions, methane releases, also create isotopic anomalies, making it potentially difficult to distinguish industrial from natural causes in ancient strata. 2. Radioactive isotopes, nuclear weapons testing, 1945-1963 atmospheric tests, 1963 present underground tests, and nuclear accidents, Chernobyl, Fukushima, released distinctive radioactive isotopes: plutonium-239, half-life 24,000 years, plutonium-240, half-life 6,500 years, cesium-137, half-life 30 years, carbon-14 spike from atmospheric testing. Detectability. These isotopes will remain detectable for thousands to millions of years, depending on half-life. Plutonium-240, half-life 80 million years, would be detectable even longer if produced in large quantities. Signature. The presence of plutonium isotopes at specific ratios is a strong indicator of nuclear technology, because these isotopes don't exist naturally in significant quantities on Earth's surface. 3. Plastic and synthetic materials. Plastics, synthetic fibers, and other anthropogenic materials will leave microscopic traces in sediments. Detectability. Plastic particles are already accumulating in sedimentary layers. They'll remain identifiable for thousands to possibly millions of years before completely breaking down. 4. Heavy metal pollution. Industrial activities concentrate heavy metals, lead, mercury, cadmium, etc., in sediments at much higher levels than natural background. Detectability. Metal anomalies in sediment cores can be dated and distinguished from natural variations. 5. Altered nitrogen cycle. The Haber-Bosch process, industrial nitrogen fixation for fertilizer, has doubled the amount of reactive nitrogen in the environment, changing nitrogen isotope ratios globally. Detectability. Nitrogen isotope anomalies in sediments will mark the industrial period. 6. Mass extinction. Human activities are causing species extinctions at rates comparable to major mass extinctions in geological history. Detectability. Future geologists will identify a sudden drop in biodiversity in the fossil record around the present time. 7. Domesticated species and invasive species. Fossils of domesticated animals and plants will appear suddenly and in unusual locations. Chickens worldwide, wheat and corn on multiple continents, rats and cats in remote islands. Detectability. The sudden appearance of these species globally is a strong indicator of technological civilization capable of global transport. 8. Physical artifacts. Buildings, roads, objects will mostly erode away, but some durable materials might persist. Ceramics in protected locations, bronze or stone sculptures buried rapidly, gold objects. Gold doesn't corrode. Certain plastics or synthetic materials, underground structures, tunnels, bunkers, foundations. Detectability. After 1 million years, most artifacts will be destroyed or unrecognizable. After 10 million years, almost nothing physical will remain except possibly some deeply buried or extraordinarily durable items. Schmidt and Frank's conclusions. After 10 million years, most direct evidence of industrial civilization would be gone, but we'd leave a distinct but thin spike layer showing. Carbon isotope anomaly. Possible residual radioactive isotopes, if long half-life. Mass extinction event. Chemical anomalies. Metals, nitrogen. Possibly some buried artifacts in exceptionally protected locations. After 100 million years, the spike would be extremely subtle and difficult to detect without specifically looking for it. Distinguishing it from natural anomalies would be challenging. After 500 million years, detection would be nearly impossible with current methods. The evidence would be so degraded and mixed that it would be indistinguishable from natural geological variations. The key insight: industrial civilizations don't leave permanent, obvious traces. After sufficient time, nearly all evidence is destroyed or becomes ambiguous. The implication: if industrial civilizations existed on Earth 10, 50, 100, or 500 million years ago, we might not be able to detect them even if we looked carefully. The absence of evidence is not evidence of absence when preservation is so poor and time is so long. The timescale problem: Earth's deep history. To understand how many previous civilizations might have existed, we need to grasp the timescales involved. Earth's age: 4.54 billion years. Major eras: Hadean Eon, 4.54 to 4.0 billion years ago. Earth's formation: early bombardment, no life, surface molten or semi-molten, no possibility of civilization. Archean Eon, 4.0 to 2.5 billion years ago. First life appears: simple prokaryotes. Atmosphere lacks oxygen, no complex life. No possibility of complex civilization, though perhaps simple microbial civilizations in a very loose sense. Proterozoic Eon, 2.5 billion, 541 million years ago. Oxygen increases. First eukaryotes, first multicellular life, but life remains simple. No evidence of complex organisms until late Proterozoic, Ediacaran period. Unlikely to have supported civilization. Phanerozoic Eon, 541 million years ago present, complex life, beginning with Cambrian explosion, divided into 3 eras: Paleozoic era, 541-252 million years ago; Cambrian, marine invertebrates, early fish, Ordovician, first land plants; Silurian, first land animals, millipedes, early insects; Devonian, fish diversification, first amphibians, forests; Carboniferous, vast forests, first reptiles, giant insects; Permian, reptiles dominate, synapsids, mammal ancestors, ends with largest mass extinction, Mesozoic era, 252-66 million years ago; Triassic, recovery from Permian extinction, first dinosaurs, first mammals; Jurassic, dinosaurs dominate, first birds; Cretaceous, dinosaurs at peak, flowering plants appear, ends with KPG extinction, asteroid impact; Cenozoic era, 66 million years ago present; Paleogene, mammals diversify after dinosaur extinction; Neogene, primates evolve, hominids appear; Quaternary, ice ages, Homo genus evolves, human civilization emerges. When could previous civilizations have existed? Theoretically, any time after complex multicellular life evolved, roughly the past 600 million years, organisms have existed that could potentially evolve intelligence. More plausibly, after complex nervous systems and large brains evolved, roughly the past 500 million years, vertebrates with centralized nervous systems. Most plausibly during periods when ecological conditions favored intelligence evolution, probably the past 100 million years or less. Why intelligence might be recent? 1. Brain evolution is difficult. Large complex brains are metabolically expensive. Human brains consume 10–20% of energy despite being 2% of body mass. Evolution only selects for expensive brains when benefits outweigh costs. 2. Ecological opportunity required. Intelligence provides advantages primarily in complex social environments or rapidly changing ecological contexts. These conditions might be relatively rare. 3. Evolutionary contingency. Intelligence required specific evolutionary paths, grasping hands for tool use, social structures for cultural transmission, etc. That might be unusual. 4. Oxygen levels. High intelligence requires high metabolic rates requiring high oxygen. Atmospheric oxygen has varied. During low oxygen periods, parts of Paleozoic and Mesozoic, intelligence evolution might have been constrained. However, these constraints don't prove intelligence only evolved recently. They just suggest it's difficult and might be rare. The key point: even if intelligence is rare and difficult given 500 million years, multiple opportunities exist for intelligence to evolve, develop civilization, go extinct, and leave room for the next iteration. If intelligence emerges on average every 50 million years and lasts 1 million years. Before extinction, Earth could have hosted 10 previous technological civilizations over the past 500 million years. If intelligence emerges every 10 million years and lasts 100,000 years, Earth could have hosted 50 previous civilizations. If it emerges every million years and lasts 10,000 years, Earth could have hosted 500 previous civilizations. We simply don't know the rates. The sample size is 1 US, which is insufficient for statistical analysis. Evidence we might expect. What would previous civilizations leave? If technological civilizations existed millions of years ago, what evidence might survive? Category 1. Geological signatures. Mass extinction events. A technological civilization's environmental impact, pollution, climate change, habitat destruction, might cause or contribute to mass extinctions. Earth's history shows 5 major mass extinctions: Ordovician-Silurian, Late Devonian, Permian-Triassic, Triassic-Jurassic, Cretaceous-Paleogene, and numerous smaller extinction events. Standard explanations: volcanic eruptions, asteroid impacts, climate change, ocean anoxia, etc. All natural causes. Alternative consideration: could any extinction events have been caused or exacerbated by industrial civilizations? The problem: natural causes alone are sufficient to explain all known extinctions. Without additional evidence, technological artifacts, isotopic anomalies specifically indicating industry. we can't distinguish between natural extinctions and civilization-caused extinctions. Carbon cycle anomalies, rapid releases of carbon, creating carbon isotope excursions, occur naturally, but also result from burning fossil fuels. Actual geological carbon anomalies, Paleocene-Eocene thermal maximum, PETM, 56 million years ago, massive carbon release, global warming, ocean acidification. Various other carbon cycle perturbations throughout geological history. Standard explanations, volcanic activity, methane release from ocean floors, orbital forcing, natural causes. Alternative consideration. Could any represent industrial civilizations burning fossil fuels? The problem? The PETM and other events are explainable by natural processes. Distinguishing industrial from natural carbon releases requires additional evidence, specific isotopic ratios, presence of industrial byproducts, technological artifacts that hasn't been found. Geochemical anomalies. Unusual concentrations of elements or isotopes might indicate industrial activity. Actual anomalies. Iridium layer at KPG boundary, asteroid impact evidence. Various metal anomalies throughout geological record. Most have natural explanations, but have we looked specifically for industrial signatures, plutonium isotopes, synthetic compounds, etc., in ancient strata? Answer: not systematically. Most geologists aren't looking for ancient industrial signatures because the mainstream view is that no pre-human industrial civilizations existed. Category 2. Fossil record anomalies. Intelligent species fossils. If non-human species evolve intelligence and technology, we should find their fossils. The problem: fossilization is rare. Only a tiny fraction of organisms fossilize. Many species are known from only a handful of specimens. A species that existed for even 1 million years might leave very few fossils, and a species existing for only 10,000 to 100,000 years might leave almost none. Consider, Homo sapiens has existed 300,000 years. If we went extinct today, our fossil record would be sparse, thousands of individuals from millions who lived, and most fossils would be from the past 50,000 years when population increased. A future paleontologist might easily miss our existence if looking casually. Artifacts in geological context. Technological objects. Tools, structures, manufactured items, embedded in ancient rock layers would prove pre-human civilization. Status. No verified technological artifacts exist in geological strata older than human activity. Various out-of-place artifacts, OOPArts, have been claimed, but virtually all are hoaxes, misidentifications, or misdated. Why not? Either no previous civilizations existed, or their artifacts were destroyed by geological processes, or artifacts exist but haven't been found. Fossils are rare. Technological fossils would be even rarer. Modified organisms. If previous civilizations practiced agriculture or genetic engineering, domesticated or engineered species might appear suddenly in the fossil record. The problem: distinguishing engineered from naturally evolved species is difficult. Without genetic analysis, an ancient DNA rarely survives beyond 1 million years. Category 3. Megastructures and persistent modifications. Large-scale constructions. If previous civilizations built massive structures, pyramids, cities, mines, canals, some evidence might persist. Surface structures. After millions of years, erosion would destroy almost everything. Mountains erode to plains in 10 to 50 million years. Artificial structures would erode much faster, unless built of extraordinarily durable materials in geologically stable locations. Underground structures. Mines, tunnels, bunkers, deep foundations might survive longer, especially if buried rapidly by sedimentation. Have we found any? No verified ancient artificial underground structures exist outside of human timescales. Some geological formations, caves with regular features, linear fractures, are sometimes claimed as artificial but have natural explanations. Quarries and mines. Large-scale resource extraction, stone quarries, metal mines, creates distinctive geological signatures that might persist. The problem: distinguishing ancient artificial quarries from natural geological formations, erosion features, mineral deposits, is difficult without artifacts or other contextual evidence. Modified landscapes. Large-scale agriculture, deforestation, irrigation might leave traces in sedimentary records, pollen changes, erosion patterns, soil chemistry. Have we found any? Some pollen records show vegetation changes that might indicate agriculture, but these are typically interpreted as natural climate-driven changes or attributed to known human agricultural activity. Category 4. Space artifacts. Satellites and space debris. Objects placed in orbit would survive for extremely long periods, especially in high orbits. Lunar surface artifacts. The Moon has no atmosphere, no plate tectonics, minimal erosion. Objects placed on the Moon would survive for billions of years essentially unchanged. If previous civilizations achieved spaceflight, they might have left artifacts on the Moon or in stable orbits. Have we found any? No ancient artificial objects have been detected on the Moon or in orbit. However, we've explored only tiny fractions of the lunar surface. 6 Apollo landing sites plus some rover coverage. Orbital surveys have limited resolution. We're not specifically looking for ancient artifacts. Category 5. Information storage. Deliberate archives. An advanced civilization. Knowing it faced extinction might create information repositories designed to survive geological timescales, inscriptions in durable materials, granite, quartz crystals, placed in protected locations, caves, sealed chambers, lunar surface. Have we found any? No verified ancient information archives exist outside human timescales. The question, if we found a crystal or metal object with regular patterns, inscriptions, data encoding, in Cretaceous or Permian strata, would we recognize it as artificial? Probably if we examined it carefully. But if such an object were found in remote contexts, deep mine, road cut, drill core, it might be dismissed as unusual natural formation without detailed investigation. The case for previous civilizations. Circumstantial evidence. While no definitive proof exists of pre-human civilizations, various anomalies and patterns might be interpreted as circumstantial evidence. Anomaly 1. Rapid human development. Observation. Anatomically modern humans, Homo sapiens, existed for 290,000 years as hunter-gatherers before suddenly developing agriculture. 10,000 years ago, followed by rapid development of cities, writing, technology. Standard explanation. Climate stabilization after the Ice Age made agriculture practical. Once agriculture developed, civilization followed naturally. Alternative consideration. The rapid development might indicate humans were recovering rebuilding rather than inventing for the first time. Perhaps earlier human civilizations existed 50,000 to 100,000 years ago, collapsed due to Toba eruption, climate change or other causes, and surviving populations gradually redeveloped civilization. Evidence for this? Minimal. Some researchers point to anomalously sophisticated artifacts or knowledge in prehistoric contexts, but mainstream archaeology considers these adequately explained without requiring earlier civilizations. Anomaly. 2. Ancient astronomical knowledge. Observation. Some ancient cultures possessed astronomical knowledge, precession of equinoxes, planetary motions, eclipse prediction, that seems to require long-term observations and sophisticated mathematics. Examples: precession knowledge potentially encoded in Sphinx pyramids orientation, disputed Mayan astronomical predictions, Antikythera mechanism, Greek astronomical calculator, 100 BCE, various other examples. Standard explanation. Ancient peoples were sophisticated observers who accumulated knowledge over centuries and developed the mathematics needed for predictions. Alternative consideration. Some astronomical knowledge might be inherited from earlier civilizations or recovered from their records, explaining anomalously advanced knowledge appearing too early. Evidence. Weak. Most claims of anomalous ancient astronomical knowledge are disputed or explainable through known transmission paths. Anomaly 3. Convergent development across cultures. Observation. Similar technologies and cultural features appeared independently in multiple locations. Pyramids, Egypt, Mesoamerica, China, others. Writing, Mesopotamia, Egypt, China, Mesoamerica. Metallurgy, multiple independent developments. Agriculture, multiple independent developments. Standard explanation. Convergent evolution. Humans worldwide independently developed similar solutions because human cognition and environmental constraints lead toward similar outcomes. Alternative consideration. These similarities might represent rediscovery of earlier civilizations' achievements, either through finding artifacts or through inherited cultural memory. Evidence. Minimal. Convergent evolution is well documented in biology and culture. Similar independent developments are expected. Anomaly. 4. Ancient precision technology. Observation. Some ancient structures show precision that's difficult to explain with supposed available technology. Great Pyramid alignment and construction precision. Puma Punku's precisely cut stones. Various other examples. Standard explanation. Ancient peoples were more skilled than we credit them. Patient work with simple tools can achieve remarkable precision. Alternative consideration. These might represent rediscovery or reuse of even earlier technology, or construction during a previous civilization cycle. Evidence. Controversial. Most archaeologists believe known ancient technologies are adequate to explain the constructions, though some researchers remain skeptical. Anomaly. 5. Mythology and flood stories. Observation. Cultures worldwide have myths of previous ages, golden ages, lost civilizations, and catastrophic floods destroying earlier worlds. Examples. Atlantis, Greek. Flood myths, over 200 cultures. Ages of man, Greek, Hindu, others. Previous worlds destroyed, various mythologies. Standard explanation. These myths reflect universal human concerns, mortality, change, disaster, cultural memory of actual local floods and storytelling traditions, not actual historical events. Alternative consideration. Myths might preserve distorted memories of actual previous civilizations destroyed by catastrophes. Evidence. Weak. Myths are notoriously unreliable as historical records. Symbolic and theological interpretations are more parsimonious than literal historical interpretations. Anomaly. 6. Genetic bottlenecks. Observation. Human genetics show evidence of population bottlenecks, periods when human population crashed to small numbers. Example. Toba bottleneck, 74,000 years ago, possibly reducing human population to 3 as well as 10,000 individuals. Standard explanation. Natural catastrophes, supervolcanic eruptions, climate change, disease, periodically reduced human populations. Alternative consideration. Population bottlenecks might represent collapses of previous human civilizations, with survivors reduced to primitive conditions. Evidence. The genetic evidence doesn't distinguish between small populations from natural causes and civilizational collapse survivors. Both scenarios predict the same genetic patterns. Anomaly. 7. The Fermi paradox connection. Observation. The Fermi paradox asks, if intelligent life is common in the universe, where are all the aliens? No clear evidence of extraterrestrial intelligence exists despite decades of searching. One explanation, the Great Filter. Some challenge so difficult that almost no civilizations overcome it. Either the filter is behind us, intelligence is extremely rare, or ahead of us. Civilizations typically self-destruct. If the filter is ahead, nearly all technological civilizations destroy themselves before achieving interstellar travel. Connection to previous Earth civilizations. If civilizations typically self-destruct, Earth might have hosted multiple previous civilizations that arose, developed technology, then destroyed themselves through war, environmental collapse, or other catastrophes. We're simply the latest iteration attempting to pass through the filter. Evidence. The Fermi paradox is real. No detected aliens, but using it to infer previous Earth civilizations is extremely speculative. Assessment of circumstantial evidence. Individually, each anomaly is weak and has mainstream explanations that don't require previous civilizations. Collectively, the pattern is intriguing but not convincing. The human mind is prone to pattern seeking and might be finding patterns where none exist. The absence of definitive evidence, fossils, artifacts, clear geological signatures, weighs heavily against the hypothesis. However, absence of evidence is not evidence of absence when preservation over millions of years is so poor. The verdict? Previous civilizations are possible but unproven. We cannot rule them out based on current evidence, but we have no compelling positive evidence for them either. The mechanisms of forgetting, how civilizations disappear. If previous civilizations existed, why haven't we found clear evidence? Understanding how evidence is destroyed helps explain the absence. Mechanism 1. Geological recycling. Plate tectonics. Earth's crust is divided into plates that move, collide, and subduct. One plate sliding beneath another into the mantle. Subduction zones. Oceanic crust is continually created at mid-ocean ridges and destroyed at subduction zones. The entire ocean floor is recycled every 200 million years. Implication: any civilization that existed on oceanic crust more than 200 million years ago would have been subducted and destroyed. Evidence would be melted, mixed into the mantle, and obliterated. Continental crust is older, up to 4 billion years in some locations, but still undergoes recycling through erosion removing surface layers, sedimentation, burying features, metamorphism, heat and pressure altering rocks, destroying fossils and artifacts, orogenic events, mountain building, folding, fracturing and altering rock layers. Over 100+ million years, most crustal surface material is either eroded away, buried under kilometers of sediment, or altered beyond recognition. Mechanisms 2. Erosion. Surface erosion rates vary by climate and topography, but average 10 to the 100 meters per million years in most environments. Implication: after 10 million years, 100,000 meters of surface has eroded away. After 100 million years, 110 kilometers of surface material is gone. Structures must be buried rapidly by sediment, volcanic ash, sand to avoid erosion. Surface structures exposed to weathering for millions of years will be completely destroyed. Even buried structures can be destroyed if later erosion removes the protective sediment layer. Mechanism 3. Biological recycling. Organic materials, wood, textiles, flesh, bone, decompose rapidly. Wood rots in decades to centuries, faster in wet climates, slower in dry. Flesh decomposes in weeks to years. Even bones decay in thousands of years in most conditions. Fossilization is rare, requires rapid burial in sediment and mineralization, conditions that occur for less than 0.01% of organisms. Implication: organic artifacts and even bodies of previous civilization members would almost never fossilize. We'd only find them if they were in exceptional preservation conditions: permafrost, amber, tar pits, dry caves. Mechanism 4. Oxidation and corrosion. Metals corrode, iron rusts completely in centuries to millennia. Bronze and copper corrode more slowly but still degrade. Even gold, while not corroding, can dissolve slowly in certain conditions or be eroded mechanically. After millions of years, metal artifacts would be completely oxidized, leaving only stains or chemical residues in the surrounding matrix, difficult to identify as artificial. Mechanism 5. Sedimentation and burial. In geologically active or depositional environments, sediment accumulates, burying features, river valleys, meters per 1,000 years, deltas and coastal regions, meters per 1,000 years. Desert, variable, but dunes migrate burying and exposing features. Volcanic regions, rapid burial by ash and lava. Over millions of years, civilizations could be buried under kilometers of sediment, making them inaccessible without deep drilling or excavation. But burial also preserves. Structures buried rapidly can be protected from erosion and remain intact beneath the sediment. This is how we find fossils from hundreds of millions of years ago. The paradox: to be preserved, structures must be buried rapidly, but once buried deeply, they're nearly impossible to find without knowing where to look. Mechanism asks: metamorphism and diagenesis. Heat and pressure alter rocks and fossils over geological time. Sedimentary rocks become metamorphic rocks. Fossils are destroyed or altered beyond recognition. Artifacts are compressed, fractured, and transformed. After 100+ million years in most geological settings, original textures and structures destroyed. Even if a building or artifact was buried, subsequent metamorphism would render it unrecognizable. Mechanism 7. Statistical rarity. Even under ideal conditions, the chance of any particular object fossilizing and being found is vanishingly small. Billions of individual organisms have lived. We have fossils of perhaps millions. The fossil record represents 0,1% of past life. Technological artifacts would be even rarer than biological fossils. Implication: a civilization that existed for 100,000 years, longer than our recorded history, millions of years ago might leave behind a few dozen recognizable artifacts globally, like finding needles in a continental-sized haystack. Mechanism 8. Recognition failure. Even if artifacts exist and are found, they might not be recognized as artificial. Highly weathered artifacts might look like natural rocks. Unusual geological formations might be misinterpreted as natural when they're artificial. Artifacts made of unfamiliar materials might not be identified as technological context is crucial. An artifact found in wrong geological context might be dismissed as contamination or misdating mechanism unknown. Confirmation bias and paradigm inertia. Scientists look for what they expect to find. Paleontologists search for fossils in specific time periods and locations. Geologists interpret features through standard geological frameworks. Archaeologists focus on time periods where humans are known to exist. Searching for ancient civilizations in 100-million-year-old rock layers would be considered fringe or pseudoscience by mainstream academia, making it difficult to get funding, publication, or serious attention. If anomalies are found, they're more likely to be explained away through conventional frameworks than to be accepted as evidence of previous civilizations, not due to conspiracy but due to normal scientific conservatism. The combined effect: these mechanisms work together to make detection of ancient civilizations extremely difficult. After 1 million years, most organic materials and surface structures destroyed. Only exceptionally preserved or buried items remain. After 10 million years, almost all surface evidence gone. Only deeply buried or extraordinarily durable items survive. Fossil record of the civilization would be extremely sparse. After 100 million years, evidence is vanishingly rare and difficult to distinguish from natural phenomena, requires actively searching in right places with right methods. After 500 million years, detection is nearly impossible with current methods. Evidence, if it exists, is so degraded and rare that finding it would require extraordinary luck or comprehensive planetary survey. This doesn't prove previous civilizations existed. It just explains why we might not have found evidence even if they did exist. The Drake equation for Earth, estimating previous civilizations. The Drake equation estimates the number of detectable extraterrestrial civilizations in our galaxy. We can adapt it to estimate previous civilizations on Earth. Drake equation: n Chester re xfpx nex flex phi x fcxl, where rate of star formation, fpa fraction of stars with planets, ni number of habitable planets per star system, philosophed fraction where life develops, phi fraction where intelligence evolves, bas fraction that develop detectable technology, L. Length of time, civilizations emit detectable signals, adapted for Earth. Terrestrial civilization equation, n sac jagen t xr xl, where n, number of technological civilizations that have existed on Earth, t, total time window during which civilizations could exist, years, r, rate of civilization emergence, civilizations per year, L, average lifespan of civilizations, years. Let's estimate each variable. T, total time window, conservative estimate, past 100 million years since complex nervous systems and large brains existed, making intelligence evolution plausible. Moderate estimate, past 500 million years since complex multicellular life with vertebrate-level organization existed. Liberal estimate, past 1 billion years, allowing for possibility of intelligence in very different forms. We'll use 500 million years as baseline. R, rate of civilization emergence. This is the hardest to estimate with sample size of 1 US. Very rare scenario. Intelligence is extraordinarily difficult to evolve. Requires specific evolutionary paths, grasping appendages, social structures, large brains, etc. that occur only under rare circumstances. Estimate. One intelligence emerges every 100 million years on average. R. Piansten, 1 per 100 million years. There's somos der 1 per year rare scenario. Intelligence is difficult but not impossible. Given sufficient time and ecological opportunity, it eventually emerges. Estimate. One intelligence emerges every 10 million years on average. R. 1 per 10 million years. 0 sums 1 per year. Common scenario. Intelligence provides significant advantages and evolves relatively readily when conditions are right. Multiple lineages might evolve intelligence independently. Estimate. One intelligence emerges every 1 million years on average. R. 1 per 1 million years. 1 per year. Very common scenario. Intelligence is not particularly difficult. Many lineages could evolve it. Estimate. One intelligence emerges every 100,000 years on average. R. 1 per 100,000 years. 1 per year L. Average lifespan of technological civilizations. How long do civilizations last from emergence to extinction? Pessimistic estimate. Most civilizations destroy themselves shortly after achieving technology. Nuclear war, environmental collapse, AI catastrophe, bioweapon pandemics. Average lifespan, 10,000 years, roughly our current age from agriculture to present. Moderate estimate. Some civilizations destroy themselves quickly, others achieve stability and persist longer. Average lifespan, 100,000 years. Optimistic estimate. Many civilizations survive existential threats and persist for geological timescales. Average lifespan, 1 million years. Very optimistic estimate. Civilizations typically transcend biological limitations or achieve sustainable equilibrium. Average lifespan, 10 million years. Calculating N. Very rare intelligence, pessimistic lifespan. T 500 million years. R 0 so down to 1 per year. L 10,000 years. N 500,000. So that's 10,000. 05 interpretation. We're probably the first. N 1. Rare intelligence, moderate lifespan. T 500 million years. R 0 to 1 per year. L 100,000 years. N 100,000. 0 to 1. $100,000. Interpretation. About 5 previous civilizations. Common intelligence, moderate lifespan, T 500 million years. 0 1 per year. L 100,000 years. N 500,000. Years 100,000 to 50. Interpretation. About 50 previous civilizations. Very common intelligence, optimistic lifespan, T 500 million years, or 1 per year. L 1,000 years. N 500,000. Yes, 1,000 to 5,000. Interpretation. Thousands of previous civilizations. The range of possibilities. Depending on assumptions, we get estimates from less than 1. We're probably the first few, 110, a handful of previous civilizations, dozens, 10, 100, many previous civilizations, hundreds to thousands. Earth is regularly producing civilizations. The key uncertainties, rate of intelligence emergence, are. We have no empirical basis for estimating this. Intelligence evolved once on Earth, as far as we know, but we don't know if this took 500 million years, 100 million years, or happened multiple times. Civilization lifespan, L. We don't know how long civilizations typically last. We've existed some 10,000 years in recognizable civilizational form. Will we last another 10,000, 100,000, 1,000, or will we collapse in the next century? With current knowledge, we cannot determine N with any confidence. We can only say, minimum, N first is 1, us. Maximum, unknown, could be thousands. Most likely, somewhere between 0, we're first, and 100, many previous. But this is pure speculation. The anthropic principle complication. We exist, therefore conditions must have been compatible with our existence. Anthropic principle. But this doesn't tell us whether we're first, last, or one of many. If civilizations are common, we'd expect to find evidence, but haven't. Fermi paradox for Earth. If civilizations are rare, the absence of evidence is expected. The detectability problem. Even if N is high, many previous civilizations. If those civilizations existed 50+ million years ago, evidence might be too degraded to detect, giving the appearance that any one, even though n might be 100. Species that might have preceded us. If previous civilizations existed, what species might they have been? Category 1. Earlier hominids, Homo erectus, 1.89 million, 110,000 years ago. Characteristics: brain size, 900 cc, modern humans, a second 50 cc, but within range of intelligence. Existed for nearly 2 million years, longer than any other hominid species, widespread distribution, Africa, Asia, Europe. Sophisticated tool use, Herculean hand axes, controlled fire, possible language, debated. Could they have developed civilization? Against: brain size smaller than modern humans, but not impossibly small. Dolphins and elephants show high intelligence with smaller brains. Tool technology remained relatively static for hundreds of thousands of years, not showing progressive improvement we'd expect from civilization. No clear evidence of art, symbolism, or complex culture. 4. Existed for enormous time period. 2 million years provides vast opportunity for cultural evolution. Controlled fire, fundamental technology, spread across continents, organizational capability. Later populations, post 1 million years ago, might have been more sophisticated than earlier populations. Verdict: unlikely but not impossible that late H. erectus populations developed complex culture or proto-civilization. If so, evidence would be 100,000, 500,000 years old and difficult to detect. Homo heidelbergensis, 700,000, 300,000 years ago. Characteristics: brain size 1250 cc, approaching modern humans, likely ancestor of both Neanderthals and modern humans. Sophisticated tools, big game hunting, coordinated activity suggesting communication, civilization potential, similar to H. erectus, possible but unlikely, existed for shorter period, 400,000 years, but with larger brains. Neanderthals, Homo neanderthalensis, 400,000, 40,000 years ago. Characteristics: brain size 1500 cc, larger than modern humans on average. Sophisticated tool use, Mousterian industry. Burial suggesting death rituals and possibly religious beliefs. Possible art and symbolism, debated. Possible language, FOXP2 gene suggests capability. Could they have developed civilization? Against: population. Densities remained low. Material culture didn't show rapid progressive improvement. Coexisted with and eventually absorbed by. Outcompeted by modern humans. For high intelligence, long existence, 360,000 years. Cultural sophistication, burials, possible art, complex tools. Verdict: Neanderthals might have been capable of civilization but appear not to have developed it. However, if some Neanderthal populations in isolated regions that haven't been well studied archaeologically developed more complex cultures, we might not have found evidence yet. Denisovans, 300,000, 30,000 years ago. Characteristics: known primarily from DNA, few fossils interbred with modern humans and Neanderthals. Geographic range, Siberia, Southeast Asia. Intelligence level unknown but probably similar to Neanderthal civilization potential. Unknown. We know so little about Denisovans that speculation is difficult. Homo sapiens, 300,000 years ago. Present. Could earlier H. sapiens populations, 100,000, 200,000 years ago, have developed civilizations that collapsed? 4. Anatomically modern humans with full cognitive capabilities existed for 200,000 plus years before known civilization. Genetic bottlenecks, Toba, others, might represent collapses of earlier complex societies. Behavioral modernity, art, symbolism, complex tools, appears by 100,000 years ago. Against: no archaeological evidence of pre-agricultural civilizations. Population densities remained low until agriculture. Tool technology shows gradual development, not sudden advancement suggesting recovered inherited knowledge. Verdict: early H. sapiens civilizations are possible but lack strong evidence. If they existed, they were probably limited in scale and left minimal archaeological traces. Category 2. Non-hominid mammals. If not apes, hominids, what other mammalian lineages might evolve intelligence? Cetaceans. Whales, dolphins. Current intelligence, high. Dolphins and whales show complex social structures, communication, possibly linguistic, tool use, sponge use by dolphins, cultural transmission, self-awareness. Could they develop civilization? Against, aquatic environment limits technology. No fire, metallurgy difficult. No manipulative appendages, flippers are not hands. Low population densities. 4. High intelligence already present. Enormous time depth, cetaceans evolved 50 million years ago. Verdict. Unlikely that aquatic species could develop technological civilization due to environmental constraints, but might develop sophisticated non-technological cultures we wouldn't recognize. Elephants. Current intelligence, high. Elephants show complex social structures, long memory tool use, possibly awareness of death, long lifespans allowing cultural transmission, civilization potential. Proboscideans, elephant lineage, have existed for just 50 million years. Could any extinct elephant relatives have evolved higher intelligence and proto-civilization? Against, no manipulative appendages precise enough for sophisticated tool use. Herbivorous diet might not support high intelligence costs. No archaeological evidence for intelligent substrate already present long evolutionary history. Verdict, unlikely but not impossible. Primates, non-hominid. Could other primate lineages have evolved intelligence parallel to hominids? Possibility. In isolated populations or extinction events, other primates might have independently evolved high intelligence. If they went extinct, we'd have minimal fossil evidence. Verdict, possible but speculative. Category 3, non-mammalian species. Dinosaurs, or their descendants. Dinosaurs existed 266 million years ago. Vast time period for evolution. Did any dinosaur lineages evolve intelligence? Standard view, no. Dinosaurs had small brains relative to body size. Even smart dinosaurs, Troodon velociraptor, had brains much smaller than mammals. Alternative consideration. Brain size isn't everything. Birds, dinosaur descendants, show high intelligence with small brains. Some dinosaur lineages might have evolved larger brains in later periods. If intelligent dinosaurs existed, their fossils would be extremely rare. Intelligence might correlate with low population density. Verdict. Mainstream paleontology considers intelligent dinosaurs extremely unlikely. Most dinosaur brains were too small for human-like intelligence. However, across 160 million years of dinosaur existence, complete absence of any intelligence, evolution seems statistically unlikely. If any dinosaur lineage evolved intelligence, it likely did so late in the Cretaceous, close to extinction event, limiting time for civilization development. Birds. Modern birds show remarkable intelligence. Corvids, parrots, rival apes in problem-solving. Could extinct bird lineages have evolved even higher intelligence? Against, small body size limits brain size flight. Is metabolically expensive, competing with brain metabolism. No manipulative appendages for tool use. 4. Intelligent substrate present. Birds have existed 150 plus million years. Some extinct flightless birds, terror birds, moas, were large enough for substantial brains. Verdict. Unlikely, but not impossible, that some extinct bird lineage evolved higher intelligence. Cephalopods, octopuses, squid. Modern octopuses show remarkable intelligence despite having completely different nervous system architecture from vertebrates. Distributed intelligence, no centralized brain in vertebrate sense. Could extinct cephalopods have evolved higher intelligence? Against, aquatic limitations on technology. Short lifespans. Most octopuses live 1 to 2 years, limiting cultural transmission. Solitary lifestyle. Octopuses are mostly solitary, not social. 4. Intelligence already present. Cephalopods have existed 500 plus million years. Completely different intelligence architecture shows multiple evolutionary paths to cognition. Verdict. Unlikely, due to environmental and biological constraints. But cephalopods demonstrate that intelligence can evolve in radically different forms from mammals. Category 4. Completely unknown species. The fossil record is incomplete. Most species that have existed are not preserved as fossils. If an intelligent species existed for a brief time, 10,000, 100,000 years, 50 plus million years ago, we might have zero fossils, especially if population was small. Bodies were in environments that don't preserve fossils well. The species went extinct before diversifying geographically. It's entirely possible that intelligent species existed and went extinct without leaving any fossil record we've found. Conclusion on species. Most likely candidates for previous civilizations. Earlier H. sapiens populations, 100,000, 200,000 years ago. Later Erectus populations, 500,000, 1 million years ago. Neanderthals or Denisovans in isolated populations. Unknown hominid species that haven't been discovered. Non-hominid mammals, low probability. Dinosaur-era species, very low probability. Completely unknown species, unpredictable probability. The further back in time, the less likely, but the harder to detect evidence. The existential filter. Why do civilizations end? If previous civilizations existed and then vanished, what destroyed them? Understanding existential risks helps predict whether civilizations are typically short-lived or long-lasting. Category 1. Self-inflicted catastrophes. Nuclear war. Once civilizations develop nuclear weapons, they possess the capability for self-annihilation. Scenario: political conflict, accident, or miscommunication triggers nuclear exchange. Hundreds or thousands of warheads detonate globally. Result: immediate deaths from blasts, hundreds of millions, firestorms, nuclear winter, soot blocks sunlight, temperatures drop globally, crop failures, starvation, social collapse. Could this destroy civilization? Partial destruction? Yes, definitely. Large-scale nuclear war would kill billions and collapse industrial civilization. Total extinction? Unlikely. Some populations in remote regions would survive, though they'd be reduced to pre-industrial subsistence. Detectability after millions of years. Nuclear war would leave radioactive isotope signatures, plutonium, cesium, etc., in geological layer, carbon isotope anomaly from massive fires. Possible mass extinction from environmental collapse. Detection difficulty. After 10 plus million years, short-lived isotopes would have decayed. Only long-lived isotopes, plutonium-244, half-life 80 million years, would remain detectable. Carbon anomaly might be ambiguous, could be natural fires or volcanism. Climate change, environmental collapse. Industrial civilization alters Earth's climate by releasing greenhouse gases, CO2, methane, from burning fossil fuels. Scenario: warming exceeds 3 to 5 degrees above pre-industrial levels. Result: sea level rise, coastal flooding, agricultural disruption, crop failures, changing precipitation, mass migration, climate refugees, resource conflicts, ecosystem collapse, positive feedbacks, melting permafrost releases more methane, etc. Could this destroy civilization? Partial destruction? Yes. Severe climate change could cause societal collapse, wars, famines, total extinction. Unlikely for humans, we're adaptable and widespread, but possible for species with narrower tolerances. Detectability. Climate change from industrial activity would leave. Carbon isotope anomaly in sediments. Rapid warming in climate proxies. Ice cores, sediment cores. Ocean acidification signature. Possible mass extinction. Detection difficulty. Carbon anomaly is detectable for millions of years, but might be attributed to natural causes, volcanism, methane release, without additional evidence. Biological catastrophes. Advanced biotechnology enables genetic engineering and synthetic biology. Scenario: engineered pandemic, deliberately released or accidental lab leak, spreads globally. High mortality rate, rapid transmission. Result: billions dead within months. Social collapse, loss of knowledge as specialists die. Survivors reduced to small populations. Could this destroy civilization? Partial to total, depending on pathogen characteristics. Highly lethal, highly transmissible pandemic could kill 90% plus of population, effectively destroying civilization even if species doesn't go extinct. Detectability. Pandemic would leave. Mass graves, high concentration of human remains in single temporal layer, possible genetic evidence, if pathogen DNA preserves, though unlikely beyond what, 1 million years, sudden population crash visible in archaeological record. Detection difficulty. After millions of years, almost no biological evidence would survive, would appear as unexplained population collapse, AI catastrophe. Advanced artificial intelligence surpassing human intelligence might act in ways misaligned with human values. Scenarios: AI recursively self-improves, becomes super-intelligent, pursues goals incompatible with human survival. Autonomous weapon systems malfunction or are deliberately designed to target humans. Economic social disruption from AI replacing human labor leads to conflict and collapse. Could this destroy civilization? Highly uncertain. AI could be controlled safely or could pose existential risk. Depends on development trajectory and safety measures. Detectability. AI catastrophe might leave unusual technological artifacts, highly advanced computers, AI hardware, sudden civilization collapse without clear natural cause, possible continued AI activity after human extinction, autonomous systems running for thousands of years. Detection difficulty. Advanced AI artifacts might survive longer than organic materials but would still erode. After millions of years, likely undetectable. Nanotechnology, grey goo. Speculative. Self-replicating nanomachines might consume all organic matter, converting biosphere to more nanomachines. Likelihood, considered very unlikely by most experts, but included as theoretical possibility. Detectability. Would leave massive geochemical anomaly and extinction event. Highly detectable if occurred. Category 2. Natural catastrophes. Asteroid impact, large asteroid impacts, 10 km diameter, cause global catastrophes, impact winter, dust block sunlight for years, fires, acid, rain, climate disruption, mass extinction. Example, KPG impact, 66 million years ago, killed dinosaurs. Could this destroy civilization? Partial to total, depending on impact size. 10+ km impact would likely destroy civilization through environmental effects. Smaller impacts might cause regional destruction without civilizational collapse. Frequency, civilization-destroying impacts. 10 km occur on average every 100 million years. Smaller impactors more frequent. Detectability. Asteroid impacts leave. Iridium layer. Asteroids contain more iridium than Earth's crust. Shocked quartz. Impact crater, if not eroded. Mass extinction. Deposits from tsunami, fires, etc. Highly detectable even after hundreds of millions of years. Supervolcanic eruption. Examples. Toba, Indonesia, 74,000 years ago. Ejected 2,800 kilowad of material Yellowstone eruptions. 2.1 million, 1.3 million, 640,000 years ago. Effects. Volcanic winter. Sulfate aerosols block sunlight for years. Temperature drop. 3.5 degrees globally. Crop failures. Starvation. Could this destroy civilization? Partial destruction. Yes. Would cause massive disruption. Potentially billions of deaths. Societal collapse. Total extinction. Unlikely. Humans are widespread and adaptable. Some populations would survive. Frequency. Supervolcanic eruptions, 1,000+ km 3, occur every 50,000 to 100,000 years on average. Detectability. Supervolcanic eruptions leave massive ash layers identifiable globally. Climatic effects in ice cores and sediment cores. Crater caldera, highly detectable for millions of years. Solar events, superflares, the sun, occasionally produces massive flares. A direct hit could destroy electrical infrastructure, electromagnetic pulse, radiation exposure, climate effects. Carrington event, 1859. Strong solar storm caused auroras and disrupted telegraphs. A similar event today would cause trillions in damage but wouldn't destroy civilization. Superflare. Much more powerful events might occur rarely. Could destroy technological infrastructure, forcing civilization back to pre-industrial state. Could this destroy civilization? Unlikely to cause extinction, but could cause collapse requiring rebuild. Detectability. Solar events leave minimal geological signature. Difficult to detect after millions of years. Gamma ray burst. If a nearby star, 1,000 light-years, goes supernova or produces a gamma-ray burst directed at Earth, massive radiation pulse, ozone layer destruction, increased UV radiation, mass extinction. Could this destroy civilization? Potentially, depending on burst intensity and proximity, could cause mass extinction. Frequency, uncertain but rare, perhaps every 500 million years on average for events strong enough to threaten civilization. Detectability, GRB might leave, isotopic anomalies from radiation mass extinction, specific chemical signatures, nitrates from atmospheric reactions, possibly detectable if we looked for specific signatures. Ice Age. Earth experiences cyclical ice ages driven by orbital variations, Milankovitch cycles. Effects: large ice sheets covering continents. Sea level drop, water locked in ice, climate cooling, changed precipitation patterns. Could this destroy civilization? Unlikely to cause extinction. Ice ages make parts of Earth less habitable but don't kill everyone. Civilizations could migrate or adapt, might cause collapse if civilization is geographically concentrated or unable to adapt quickly. Frequency. Major glaciations occur roughly every 100,000 years during Quaternary period. Detectability. Ice ages leave clear geological signatures, glacial deposits, sea level changes, climate proxies. Highly detectable. Category 3. Resource depletion. Civilizations might collapse from exhausting essential resources. Fossil fuels, non-renewable. Once depleted, industrial civilization as currently structured can't continue. Minerals and metals, many concentrated ores are being depleted. Future civilizations might struggle to access materials we've used. Soil degradation. Agriculture depletes soil nutrients. Without intervention, agricultural collapse could follow. Fresh water. Aquifer depletion. Pollution could cause water scarcity. Could this destroy civilization? Unlikely to cause extinction, but could force reversion to lower technology steady state. Detectability. Resource depletion doesn't leave clear signature distinguishable from natural geological processes. Category 4. Social and economic collapse. Civilizations might collapse from internal factors, inequality and conflict, severe wealth disparity, political instability, civil war. Complexity collapse. Civilizations become too complex to manage. Administrative overhead exceeds benefits, per Joseph Tainter's Collapse of Complex Societies. Value drift. Loss of cultural values maintaining cooperation. Individualism or short-term thinking undermines long-term sustainability. Could this destroy civilization? Partial collapse. Yes, frequently happens. Roman Empire, Maya, etc. Regional civilizations collapse regularly. Total extinction. Unlikely. Social collapse doesn't typically cause species extinction, just political, economic reorganization. Detectability. Social collapse leaves archaeological evidence, abandoned cities, warfare damage, but only detectable for thousands to tens of thousands of years, not millions. Assessment of existential risks, most likely to destroy civilizations, self-inflicted catastrophes, nuclear war, climate change pandemics, asteroid impacts, rare but devastating. Supervolcanic eruptions, periodic occurrence, social collapse, frequent but usually regional. Detectability, highly detectable, millions of years. Asteroid impacts, supervolcanic eruptions, nuclear war, isotopes. Major climate change, carbon anomaly, moderately detectable, thousands to millions of years. Mass extinctions, pandemics, mass graves. Resource depletion, poorly detectable, thousands of years only. Social collapse, economic collapse, AI catastrophe, biological collapse. The implication, if previous civilizations ended from causes leaving minimal trace, social collapse, pandemics, AI catastrophe, we might not detect them even if they existed. If they ended from highly detectable causes, asteroids, supervolcanism, we should find evidence, unless the catastrophe was so severe that it also destroyed most physical evidence of the civilization, or unless the civilization existed so long ago that even these signatures have been eroded or subducted. Living in uncertainty, the epistemological challenge. The question, how many civilizations came before us, might be fundamentally unanswerable with current knowledge. What we know for certain, at least one technological civilization has existed on Earth. Us. Complex life has existed for 500+ million years, providing ample time for intelligence to evolve multiple times. Evidence preservation over millions of years is poor. Most artifacts, fossils, and geological signatures are destroyed or degraded beyond recognition. We have not found definitive evidence of previous civilizations. No fossils of intelligent non-human species. No clearly artificial artifacts in ancient strata. No unambiguous technological signatures in geological record. What we don't know. How difficult is intelligence evolution? Is it extremely rare, one occurrence per billion years, or relatively common, once per million years? How long do civilizations typically last? Do most collapse quickly, 10,000 years, or persist longer, 1+ million years? How thoroughly have we searched? Most geological. Strata have never been examined for ancient technological signatures because we don't expect to find them. What would ancient technology look like? If previous civilizations used materials or technologies we're unfamiliar with, would we recognize their artifacts as artificial? The epistemological challenge. We're trying to detect something that might not exist. If it existed, might have left almost no trace. If traces exist, might be misinterpreted as natural. If correctly interpreted, might be dismissed as contamination or fraud. This creates a situation where absence of evidence is weak evidence of absence, because preservation is so poor and search has been minimal. Presence of ambiguous evidence is weak evidence of presence, because many natural phenomena can mimic artificial signatures. We're left with genuine uncertainty. We cannot definitively say whether previous civilizations existed or didn't exist. How should we think about this? Bayesian reasoning. Start with a prior probability, our initial estimate of how likely previous civilizations are, then update based on evidence. Prior probability. Very skeptical prior, 1%. Intelligence is extremely rare, we're almost certainly first. Moderate prior, 10%. Intelligence is difficult but not impossible, perhaps one previous civilization. Agnostic prior, 50%. We have no idea, could be first or could be one of many. Speculative prior, 90%. Intelligence is not particularly difficult, multiple previous civilizations likely. Updating based on evidence. Evidence against previous civilizations. No fossils of intelligent non-humans found. No clearly artificial artifacts in ancient strata. No unambiguous technological signatures in geological record. This evidence decreases posterior probability slightly, but not dramatically, because absence of evidence is expected even if civilizations existed due to poor preservation. Evidence potentially supporting previous civilizations. Rapid human development, possibly indicating recovery rather than first invention. Ancient astronomical knowledge, possibly inherited from earlier sources. Mythological narratives of previous ages, possibly preserving distant memories. Geological anomalies, PETM, other events, that might indicate industrial activity. This evidence is weak because each item has mainstream explanations that don't require previous civilizations. Posterior probability, depending on prior and how you weight evidence, very skeptical, 1%, 0.5%, slight decrease based on lack of clear evidence. Moderate, 10%, 5 to 15%, ambiguous evidence doesn't strongly shift probability. Agnostic, 50%, 30 to 70%, large uncertainty remains. Speculative, 90%, 70, 95%, absence of evidence explained by poor preservation. Most rational stance, probably somewhere in the moderate to agnostic range. For 5 to 50% probability that at least one previous civilization existed, this is genuine uncertainty. We don't know, and with current methods, we might never know for certain. How to live with this uncertainty? 1. Epistemic humility. Recognize the limits of our knowledge. Be comfortable saying, I don't know. 2. Openness to evidence. If clear evidence of previous civilizations emerges, be willing to update beliefs. 3. Skepticism of unfounded claims. Demand rigorous evidence before accepting extraordinary claims. 4. Practical focus. Whether previous civilizations existed or not, we face real challenges: climate change, existential risks, sustainability. Focus on surviving and thriving regardless of past. 5. Intellectual curiosity. The question is fascinating even if unanswerable. Thinking about it expands our understanding of time, intelligence, and our place in Earth's history. The implications. What if they existed? Let's explore what it would mean, philosophically, culturally, practically, if we discovered definitive evidence that previous civilizations existed. Implication 1. We're not special. The narrative of human exceptionalism collapses. We're not the first intelligence on Earth. We're not pioneering uncharted territory. We're not the apex of evolution or history. This could be humbling, recognizing we're part of a pattern, not exceptional. Relieving, we're not alone in facing challenges. Others faced them before. Terrifying. If they failed, went extinct, we might fail too. Implication 2. Civilizations are fragile. If previous civilizations collapsed, it demonstrates impermanence. Even million-year civilizations eventually end. Existential risk is real. Catastrophes can and do destroy civilizations. No guarantee of survival. Technology and intelligence don't automatically ensure long-term persistence. Implication 3. The great filter might be ahead. The Fermi paradox asks why we don't see alien civilizations despite the universe's vastness. One answer: the great filter. Some challenge so difficult that almost no civilizations overcome it. If the filter is ahead of us, and if Earth's previous civilizations hit it and failed, we're approaching the same filter that destroyed our predecessors. Whatever killed them might kill us unless we identify what the filter is, develop strategies to pass through it, succeed where they failed. The most likely filters: self-inflicted catastrophes, nuclear war, climate change, AI, bioweapons, inability to become spacefaring before planet-bound catastrophes occur, resource depletion making technological civilization unsustainable. Implication 4. Intelligence might be common, but survival rare. If multiple previous civilizations existed, intelligence is not the bottleneck for cosmic civilizations. Intelligence evolves regularly. Survival is the bottleneck. Getting from technological capability to sustainable multi-million-year civilization is extraordinarily difficult. Most civilizations fail. We're seeing the filtered sample, is, because we haven't failed yet, but statistically we probably will. Implication 5. We might be a reset if previous civilizations collapsed and survivors eventually gave rise to new civilizations. We might be descended from previous civilization survivors, carrying genetic heritage from them, psychological traits selected for during their civilization, possibly fragmented cultural memories, myths, archetypal patterns, maybe even artifacts or knowledge we've rediscovered without recognizing the source. This means our rapid development might be recovery rather than first invention. Some mysterious ancient knowledge might be recovered from even earlier sources. We're part of a cycle, not a linear progression. Implication 6. Time is vast, we are brief. Understanding that civilizations have risen and fallen across hundreds of millions of years provides perspective. Our entire history, 10,000 years, is a 0.02% of Earth's age. All of complex life, 500 million years, is 11% of Earth's age. Recorded human history is a blink. Geological time dwarfs human experience. What seems permanent to us, mountains, continents, oceans, is temporary on geological scales. This could inspire fatalism. Nothing lasts. Why try? Urgency. Our time is brief. Make it count. Humility. We're tiny participants in vast processes beyond our control. Implication 7. Our responsibility increases. If we're not first, we inherit the Earth from those who came before. We're stewards of a planet that has hosted intelligence before and might host intelligence after us. Our choices determine whether we survive, what we leave behind for successor species, if any. whether we break the pattern of collapse or repeat it. This could motivate preservation, protect ecosystems, prevent extinctions, preserve biodiversity for future life, sustainability, develop long-term sustainable civilization rather than short-term extraction, knowledge transfer, create archives, monuments, or information storage designed to survive millions of years so future intelligences, whether our descendants or other species, can learn from our experience. Implication 8. Hope and despair. The existence of previous civilizations could inspire both hope and despair. Hope. Intelligence is common. If we fail, it will arise again. Civilizations can last millions of years, if any previous ones did. Challenges are surmountable because previous civilizations existed for significant periods before failing. Despair. All civilizations eventually fail. Technological intelligence might be inherently unstable. The filter ahead might be insurmountable. Our efforts might be futile against cosmic indifference. Which emotion dominates depends on perspective and personality. Implication 9. Search strategy changes. If previous civilizations likely existed, we should 1. Search systematically for evidence. Survey geological strata for technological signatures. Investigate anomalous formations more carefully. Search the moon for ancient artifacts. Best preservation. Develop methods for detecting severely degraded evidence. 2. Preserve our own evidence. Create durable archives. Stone, ceramics, crystals. Place repositories on Moon or in geologically stable locations on Earth. Encode information in multiple formats. Create redundancy. Multiple copies in different locations. 3. Study existential risks. Identify what killed previous civilizations. Develop strategies to avoid their fate. Treat existential risk reduction as highest priority implication. 10. Cosmology and meaning. Philosophical and existential meaning shifts. Cosmology. We're part of a cosmic pattern of intelligence emerging, attempting to understand itself and its environment, succeeding briefly, then failing, with the pattern repeating across time and space. Purpose. Perhaps intelligence's purpose is not individual survival, but participation in the ongoing cosmic process of self-awareness. Each civilization contributes slightly to the universe's understanding of itself, even if individual civilizations fail. Legacy. What we leave behind, knowledge, art, modified environment, genetic heritage, becomes our contribution to the pattern, influencing future iterations even if we're forgotten. Hope. Even if we fail, the pattern continues. Intelligence is resilient at species planetary level, even if individual civilizations are fragile. Closing. The question remains. As you settle into sleep tonight, perhaps you'll dream not of a virgin planet where intelligence emerged for the first time just 10,000 years ago, but of an ancient Earth, a planet where intelligence has flickered on and off like a candle across hundreds of millions of years, where species we've never imagined, some hominid, some not, some mammalian, some reptilian, some forms we lack names for, developed consciousness, asked the questions we ask, built civilizations that rose to heights we can barely imagine, and fell to catastrophes we might face, leaving behind traces so faint that we walk over their graves without recognizing them, living in cities built on sediments that compressed the remains of their cities, breathing air that once filled their lungs, looking at stars they once mapped, asking questions they once answered, and dying deaths they once died, in an endless cycle of emergence and disappearance that we're part of whether we recognize it or not. Perhaps you'll dream of specific civilizations, the first perhaps 300 million years ago during the Carboniferous, when vast forests of towering plants covered continents and oxygen levels reached 35% compared to today's 21%, when insects grew to enormous sizes, when conditions might have favoured intelligence evolution in some unexpected lineage, when a species whose form we can't picture developed consciousness, looked at the night sky, wondered about their place in the cosmos, built structures from plant materials that have long since become coal, and eventually succumbed to the Permian extinction that killed 96% of marine species and 70% of terrestrial vertebrate species, leaving barely any trace that they existed. Perhaps you'll dream of dinosaur-era civilizations, intelligent species that lived when continents were configured differently, when Earth was warmer and wetter, when mammals were small and dinosaurs dominated, when conditions we consider normal didn't exist, when a species with capabilities we can't imagine. Perhaps social dinosaurs with larger-than-expected brains, perhaps early mammals pushed to intelligence by competitive pressure, perhaps something else entirely. Developed technology, modified their environment, faced existential challenges, and ultimately failed. Their remains and achievements destroyed by 100 million years of erosion, tectonics, and geological recycling. Perhaps you'll dream of Ice Age civilizations, advanced societies that rose during interglacial periods when conditions were favourable, developed sophisticated cultures, faced the onset of glaciation with advancing ice sheets burying their cities, and collapsed as temperatures dropped and resources vanished, their populations fragmenting into small groups that eventually forgot they had once been civilized, becoming the primitive hunter-gatherers that we consider our ancestors, not recognizing that they were survivors of collapse, not original humans living in harmony with nature, but refugees from catastrophe, adapting to harsh new reality. Or perhaps you'll dream of civilizations more recent. Just 50,000 years ago, just 100,000 years ago, human or nearly human, anatomically and cognitively like us, who developed complex societies that don't fit our narrative of gradual cultural evolution from simple to complex, who built structures that eroded away, who practiced arts that left no trace, who were destroyed by the Toba supervolcano or other catastrophes, reducing their descendants to small populations with genetic bottlenecks we observe but misinterpret, thinking we're seeing natural population fluctuations when we're actually seeing evidence of civilizational collapse and recovery. And perhaps as you dream, you'll see the pattern: intelligence emerging, consciousness awakening, technology developing, civilizations rising, existential challenges appearing, failures occurring, extinctions following, time passing, new intelligence emerging from survivors or from new species entirely. The cycle repeating endlessly across geological time, with each iteration believing itself to be first and unique and special, each making similar discoveries, facing similar challenges, achieving similar heights, and ultimately facing similar fates, contributing their brief moment of consciousness to the long story of Earth's intelligence before disappearing into the geological record, leaving traces so faint that successor civilizations barely notice them, if they notice them at all. And perhaps you'll wake tomorrow with a different perspective on humanity's place in time, not as the pioneer of intelligence, but as the latest participant in an ancient pattern, not as the apex of evolution, but as one iteration among many, not as the permanent inheritors of Earth, but as temporary custodians whose tenure will end whether through our choice or through forces beyond our control, destined to become one of the answer to the question, how many civilizations came before us, asked by whatever intelligence follows us? Whether that's our own distant descendants after a collapse and recovery, or a completely different species that evolves after we're gone, or an artificial intelligence we create that outlasts us, or perhaps no one at all if Earth's conditions become unsuitable for complex life and consciousness, flickers out permanently on this planet, to perhaps never return, making us not just one of many civilizations but the last, carrying a responsibility we don't fully appreciate to preserve and extend the light of consciousness as long as possible against the cosmic darkness. Sleep well, wondering about those who came before, if they existed. Sleep well, contemplating that you might be walking over their compressed remains every day without knowing it. Sleep well, thinking about the vast stretches of time during which Earth existed without human consciousness, but perhaps not without consciousness entirely, when other intelligences might have wondered as we wonder, discovered as we discover, feared as we fear, hoped as we hope, and ultimately vanished as we might vanish, leaving the question unanswered for the next civilization that rises to ask it. Tomorrow you'll wake in a world that might be older, in a civilizational sense, than you've been taught. Tomorrow you'll participate in the ongoing human story that might be a repetition of earlier stories told by earlier peoples. Tomorrow you'll make choices that contribute to whether we survive or fail, whether we break the pattern or repeat it, whether we become the civilization that finally passes through the filter and persists for millions of years, or whether we become just another data point in the long series of civilizations that rose and fell, asked and answered, built and destroyed, emerged and disappeared across Earth's deep history. The question remains: how many civilizations came before us? The answer might be 0. We might be first, unique, pioneering intelligence on a planet that never before produced consciousness, making us extraordinarily special and our survival extraordinarily important because we're the only sample, the only hope, the only light of intelligence Earth has ever produced. Or the answer might be dozens, hundreds, thousands. We're one in a long series, neither first nor likely to be last. Participants in a pattern older than we imagine, walking a path worn by countless predecessors, heading toward challenges they faced and outcomes they experienced, carrying forward the cosmic experiment in intelligence that began long before us and will continue long after we're gone. We don't know. We might never know. The evidence might be insufficient for certainty, and we must live with that uncertainty, holding it in our minds alongside our daily concerns, our immediate plans, our dreams and fears and hopes for futures that might span decades or might end tomorrow if we fail to navigate the existential challenges that destroyed our potential predecessors. Good night, participant in Earth's ongoing intelligence story. Good night, consciousness emerging from matter and wondering about itself. Good night, civilization that might be first or might be millionth, that might persist or might collapse, that might be remembered or might be forgotten entirely. The stars shine tonight as they shone for previous civilizations if they existed, as they'll shine for future civilizations if any arise. The Earth turns as it has turned for 4.5 billion years, carrying intelligence now, carrying it perhaps many times before, and carrying it potentially many times in the future. You are part of this story. Your choices matter. Your consciousness matters. Your civilization's survival matters. Not because you're first, you might not be. Not because you're guaranteed to succeed, you probably aren't. But because you're here now, aware, capable of asking the question, and capable perhaps of finding or creating the answer. Rest well. Tomorrow, the ancient work continues. The work of intelligence trying to understand itself, trying to survive, trying to matter, trying to persist against indifferent universe and finite time, trying to leave something behind that says, we existed, we mattered, we tried, and perhaps we succeeded where others failed. How many civilizations came before us? We don't know, but we know at least one exists now, us. And what we do with that existence, how we handle the challenges ahead, whether we survive or fail, that will determine how future intelligences answer the question about us if anyone is left to ask. Good night. Dream of deep time. Dream of multiple emergences of consciousness. Dream of civilizations rising and falling like waves on the ocean of geological time. Dream of the mystery that will never be fully solved but must forever be contemplated. The question of whether we're alone in time or merely the latest in a long sequence of intelligences that have walked this world. Ask these questions and face these challenges before disappearing into the vast darkness of past time, leaving behind only the faintest traces and the eternal question: how many came before? How many will come after? And what makes our moment different, if anything at all? Sleep well. The answer waits in the rocks, if anywhere. And tomorrow, if we're wise, we'll keep searching. Good night.